this is similar to the stuff that we saw yesterday, okay? So when we talk about writing a full factorization for number one, this idea of full factorization of polynomials is kind of what we're working towards with the information we're starting with and where we're heading in this unit, is we're going to learn to take polynomials that look like this and be able to factor them. Right now we can factor things that are x squared by using the box and quadratic formula and stuff like that. What we're going to learn is we're going to learn ways to factor things that have powers bigger than 2 in them with our polynomial, okay? But what we saw through our work yesterday when we looked at complete factorization is that all of these times that we cross the x-axis, especially because it crosses, are roots. So if we write this thing, let's write them as zeros first. That means that we have zeros at x equals, let's write them up here, -5, -1, 2, and 4. So since we have 4 zeros, that means that we're going to have 4 linear factors. And those things would get flipped around when we write them in here, meaning this would be x plus 5. Now, we didn't go through a real algebraic way to understand that, but let's write this as a 0. This is x equals -5 as a 0. The way that we figure out what goes inside these parentheses is we take this 0 and we make it equal to 0, meaning how do I get rid of this -5? I would add it to both sides. That would put this out here at 0 and give me x plus 5. The x plus 5 is what goes into the factored form. We're really working backwards from the factored form of finding the zeros. So then this next one here would be x plus 1, following the same pattern, and then x minus 2 and x minus 4. This is one possible factorization of this thing. Meaning because I see where it crosses the x-axis, I think it should have those roots. I'm going to write it in factored form because that's all I'm asked to do. We're not going to worry about sketching a possible graph today. But if we want to find the zeros of this, I want you to think about what the word 0 means. 0 means make this equal to 0. This is the same thing that we did when we had a quadratic where we solved each one of the parentheses for 0. Doesn't matter how many sets of parentheses I have. If I make one of them 0, 0 times anything is going to be 0. So as soon as I get 1 0 in there and all those are multiplications, I could have 20 sets of parentheses. As soon as I make 1 0, the other ones don't matter. So we solve each and every factored form for 0. And it will tell me where this thing should cross the x-axis. So this one will have three x-axis crossings. So let's see, this is 2x equals -1. So that's 1/2. So that means we should have an x-intercept of -1/2, 0. This one's going to be -3. And this one's going to be +1. Now, the reason I said we'll leave out the sketch today, we'll eventually work to that. All we really understand right at this point is that this thing it's going to cross the x-axis 3 times. At +1, -1/2, and -3. Eventually, we'll be able to look at this and look at the factored form and determine whether it's coming from the bottom and crossing through each one, or if it's coming from the top on the side. So that's why I kind of left hey, sketch these right now, because we haven't talked about how to determine end behaviors and things like that. We're just looking for where it crosses, okay? But we do know, just by looking at this and seeing the 3 factors, we know that it crosses the x-axis 3 times. So we could easily graph that thing and see what it looks like. So we're going to do the same thing for the last one. Now, I did put this squared in here. The squared does not affect the 0, because I still want to know when all of this is equal to 0. So if I look at what makes x minus 1 squared equal to 0, I got to take the square root to get rid of the squared. That leaves me x minus 1 over here. What's the square root of 0? It's still 0. So that square root doesn't affect the 0 because we're working with 0. And we end up with a positive 1 right here. So it means it crosses the x at positive 1. We get the x plus 3. We don't need the parentheses, I'm sorry. And our x plus 1. And we'll find the other two. So this is negative 3 and negative 1. So we know the 3 x-intercepts. Okay, we actually talked about it in there. This graph, if we were to look at this graph, does something special at that root at positive 1, because that power 2 means it's in there twice. So what we'd actually see at the graph there is we'd actually see it bounce. And I know that was in the video as well, but if we could look at it, anytime you get a power in there and it's an even power, what you're going to see the graph do, and I'll show you what this one does, is it's going to bounce. So let's see, we had x minus 1 squared, I remember that. X plus 3, x plus 1. If we actually graph this in Desmos and look at the graph, we see our 3 x-intercepts. We have that negative 3, that negative 1, but it does something weird at the actual 0, 1, because it has the squared, meaning that the other way you could type this is that squared means that it's in there twice. It means it also would look like that. Gives you the same graph. It's in there twice. When it gets in there an even number of times, it's going to constitute a bounce. The only one you should ever have to worry about for us is squared. Meaning anytime I see that squared, I know at that x-intercept, my graph is going to bounce. So there's our finding. Let's continue. Write a polynomial of least degree with these zeros. Now with this, we're probably going to be expected to multiply these things out. So this list, these are my x equals numbers. So that means I know I have a 0 at x equals 4, x equals 5, and x equals negative 6. The first step of this is to get it into its factored form, which is what we had right here with these parentheses, meaning I've got to work this so I get 0 on the outside to figure out what goes back in the parentheses. So since I have three zeros, I know I'm going to have 3 sets of parentheses, and I got to work my way back to figure out what should have been inside of them. So I got to solve each one of these things so they equal 0. So that's x minus 4 equals 0. So that is what goes in the first parentheses. This is x minus 5 equals 0. That goes in the second. And we add that 6 to the other side. And we get x plus 6 equals 0. And this goes in here. Now, thing to remember that this, because it's all linear factors, this is called the factored form. Most of the time when we're asked to write an equation for these things, they're not going to give us our answer in factored form. They're going to want us to take it to standard form. All standard form means is multiply it out. So we take these things and jar boxes and multiply. So x minus 4, x minus 5, so that's x squared. It's negative 4x, negative 5x, and plus 20. So this one turns into x squared minus 9x plus 20 when I multiply these two together. And then I need to multiply that by that x plus 6. So let's draw the box again and do that. So put our x plus 6 over here. X squared minus 9x plus 20 So we get x to the third minus 9x squared plus 20x plus 6x squared minus 45x. And then 20 times 6 is 120. And then remember, with this it's set up, because we had all the powers in here, the diagonals are going to add up. So we can write our answer out. So we get x to the third, negative 9 and positive 6 is negative 3x squared. 20 minus 45 is negative 25x squared. I'm sorry, 25x. And then we just have the 120. So that is the full multiplied out polynomial in standard form that has zeros at 4, 5, and negative 6, meaning we can plug this into our graph. This is where we would see it cross. And eventually what our goal is to do this process in backwards. We started with the zeros and found the polynomial. Eventually our goal when we finish this unit is to start with the polynomial, do the math, and work our way backwards to specific zeros, okay? So this one works the same way. It's got 4. One reason I do want to talk about this is I want to talk about this 1/2. So let's write them all out and we'll figure out what goes inside our parentheses. So let's do these other ones and do the 1/2 at the end. These are easy. This is x plus 2, x minus 3, and x plus 6. This one, when you write these things as factored, you're not supposed to have fractions. So the way you deal with one that is a fraction is you do this in 2 parts. To get rid of the 2 on the bottom, we would multiply it to the other side. So this ends up being 2x equals 1. And then how do I get rid of the 1 now? I would subtract it to the other side. So when you get these ones that are fractional, that will be in our factored form, they start getting numbers in front of x. And what that does is it keeps it so that we get whole numbers when we multiply everything out. So our factored form here is going to be 2x minus 1, x plus 2, x minus 3, x plus 6. And we are going to multiply all this together to get down to our standard form polynomial, because this is factored form. This down here is called standard form. So we got 2 sets to multiply with the box. I'm not going to draw the box this time for sake of space, but you would draw your boxes and you would multiply these 2 out. So let's see, this is going to give us 2x squared plus 3x minus 2 when we do that. And our last one here is going to be x squared plus 3x minus 18. And then this one gives us a much bigger grid to multiply, but this is where falling back on that grid to multiply these things out and also pay dividends when we talk about dividing today should help us out a little bit, because this is going to be a 3 by 3 because both sides have 3. So we'll list one of your polynomials on the side, one of them on the top. So 2x squared plus 3x minus 2x squared plus 3x minus 18. And you guys have done this multiplication forever, right? Just be careful, because one of those things, some of these stuff that you know you've done a bunch, you tend to rush through at the end after you did all the hard work of finding it in factored form. So just be cautious at the end. So 2x to the 4th plus 6x to the 3rd minus 36x squared. This is 3x to the 3rd 9x squared. Let's see, it's 9 times 6, so that's 54 minus 54x negative 2x squared minus 6x plus 36. Now, because I put all of each of the things I'm multiplying by has all of the powers listed in it, meaning it has squared, the first, and the constant, the diagonals are still going to add up. All my x to the thirds are in here. All my x squareds are in here. My x's are in here, and then the two that are by themselves don't need anything added to them. So let's see, we're going to get 2x to the fourth, because that's by itself. Now we just need to add these coefficients. 9x to the third. So this is 36 minus, that's 27, 29. Uh, 54 and 6 is 60. And the last one is 36. So there's our standard form answer for this one. And again, if we were to plug this into Desmos, we would see that it would cross the x-axis at those 4 spots. Like I said, right now we're practicing stuff that I know that you've seen before and kind of putting it all together into a nice pretty package, because right now we're working this problem from the top to the bottom and finding this multiplied out polynomial. Our eventual goal is going to be starting here and working back to that with all the math that goes through it, okay? That's why we're reviewing this. All right, so one more. There were a couple like this, which actually kind of took us into that original path of finding all the zeros, okay? At this point, we don't have a very good, true, and tried method for learning to factor these things. By the end of the week, we're going to learn a real specific method that will allow us to factor just about any large degree polynomial, okay? And this is actually something that we continue on and we finish in pre-cal and learn that all of them factor into a very specific way. I won't get too in depth in that. But with what we know right now, what we're working on here is you should be able to factor these things relatively, I wouldn't say relatively easily, but there are other tricks other than our end-game method we're going to learn on Thursday to factor these. So the first thing, when you look at this, always look for a common factor between everything. These all have a x in common. So since these all have an x in common, I can factor that x out. And I'm left with x squared plus 10x plus 21. And the idea is once I find one factor, all I need to do is I need to worry about factoring what's left over, which is going to be a theme that we're going to continue with. Once I find one factor and factor that out, I can take what's left over and only factor that. This factors with the box. Let's actually draw that box and factor it to review it. So we get x squared here and a 21. And we're looking for the factors of 21 that add to 10. So that has to be 7 and 3. So that means this should be a 7x and this should be a 3x. So this leaves us plus 7, x, x, and a plus 3. So all factored down, this is x, x plus 7, x plus 3. Now that means, so we factored it. This is the factored form. And the way that we can tell factored form, none of those x's have any powers per se, okay? They have powers of 1, but they don't have anything bigger than 1. At this point, to find the zeros, what makes x equal to 0? What makes, because we want, this is f of x, and we want to know when f of x is 0. So what makes the x plus 7 equals 0, and what makes the x plus 3 equals 0? So this is -7. This is -3. What makes x equal to 0? And it seems like a silly question. Well, when it's 0, right? You got to be careful when you factor out just an x, because that is also an x-intercept, or 0, of this function, meaning all of our zeros listed out are x equals 0, -7, and -3. If I went and graphed this, that's where I would see this thing cross the x-axis if I graphed up here. Okay, and really this is what we want to be able to do. But right now we're using a trick because we had to have something that had a common factor for us to get down to a quadratic, because we don't know any direct methods yet to factor anything bigger than a quadratic. We deal with something like this one. Is there a common factor yet? We can't pull out an x because this 12 doesn't have an x, and it's got to be everything. Now, eventually I'll teach you a better way to factor this, but right now these are set up very specifically, and there's one like this on the worksheet from yesterday, which is why I wanted to point this out. Look at the grouping since you got 4 things and see what they have in common and see if something special happens, meaning what's similar between x to the 3rd and 3x squared. Well, both of those things have an x in common, an x squared in common. And what's left over? X plus 3. Now I'm going to do the same thing here. What does -4x and -12 have in common? They're both factors of -4, which leaves me an x plus 3. If you ever have 4 terms and you can factor something out of each pair and get a match right here, you've actually factored, because now you only have 2 terms and they have an x plus 3 in common. So I'm going to factor that out. If I pull x plus 3 out of both of these things, what's left over for my second set of parentheses? X squared minus 4. We just pulled out a factor of x plus 3. You can actually factor what's left over because it's a quadratic. The only thing you need to remember, this is a difference of squares, but if you were to forget that, remember the middle term is 0, and you can still draw the box and factor this one, because you have x squared and you have minus 4. You want the factors of 4 that subtract and give you 0. That's got to be 2 minus 2, so it's -2x and positive 2x. So we get x minus 2, x plus 2. And this thing factors down to x plus 3, x plus 2, x minus 2. That's its factored form, and it's zeros. And I'm not going to write them this time, but we know this one gives us a -3. This one gives us the -2. This one gives us the positive 2. So there's our zeros, and there's our factored form. So this number 7 is probably the most difficult one as we go through. We won't practice this method a ton, because once we get to Thursday, we'll have a real easy way to start this that'll make this a little bit more direct. But these are 2 types of factorings you don't want to forget, because if you ever have 4 terms and you can factor common stuff out of 2 of them and get the same thing, it's a quick way to factor. They're a little bit more direct than what we're going to learn on Thursday, which is called the rational zeros theorem. And I don't want to lead too much into that because we haven't gotten there yet.